This is going to be a lesson on combining like terms using the distributive property. So, first of all, what are like terms? Well, like terms are terms that contain the same variables raised to the same powers. Okay, so let's do a couple of examples. I want to write down some terms and we're going to figure out if they're like terms or not. So are the following like terms? So number one, we have 3x and 9x. So the answer is yes, since they both have an x and it's raised to the first power. Let's try the following. 5p squared negative 1/4 p squared. Now in this case, they are still like terms because they both contain a p squared. And I'm sorry if this p squared looks like it is on the bottom. It is in fact part of the numerator here. Okay? So yes, these are like terms. Third example. How about 10x and negative 4x squared? The answer is no in this case. Even though they both have an x, notice that the power of the first x is 1, the power of this x is 2. So they are not like terms. Let's do one more of these. How about 2x squared y and yx squared? Now, even though we have an x squared y and this one is a yx squared, they are like terms because notice that the x is squared in both cases and the y is raised to the first power in both cases. So the answer is yes, they are like terms since the order of multiplication does not matter. Okay. So now I'd like to talk about coefficients. So what is a coefficient? So a coefficient is the number attached to a variable term. Okay. So let's do a couple of examples. So for these few examples, I want us to name the coefficient. So number 5, 11x. So the coefficient of 11x would be 11. Next example, 14x squared. Coefficient of this would be 14. Finally, we have negative x, y, z. Now, even though we don't see a number there, that negative, there's actually an invisible negative 1 there. So this is really the same as negative 1 x, y, z. So the coefficient would be negative 1. So why do we care about coefficients? So coefficients are what we deal with when we're actually adding and subtracting like terms. So I would just like to write this out first before we do some examples. So we're going to talk about how to combine like terms. So to add or subtract like terms, simply add or subtract their coefficients. Okay, let me do a few examples of this. So for the following examples, we're going to combine like terms. Okay. So this would be number 8. 13b minus 4b. Now in this case, these are like terms, right? We have a b in this case and a b in that case, and they are both raised to the first power. So we're just going to combine their coefficients. 13 minus 4 is 9, so this would be 9b. All right, let's try another example. We have d minus 8 plus 5d minus 1. So in this case, our like terms are d and 5d. So d plus 5d would be 6d. So I put that first. And then I have negative 8 and negative 1. That gives me negative 9. I cannot combine 6d and negative 9, though, because they're not like terms. So this is actually my final answer. Okay. Let's look at the next one. Will be a little trickier. 7/10 y squared minus 1/3 y squared. Now in this case, these are like terms because we see a y squared in both of these problems, or both of these terms. So we need to figure out what 7/10 minus 1/3 is. So our LCD of 10 and 3 is 30. So that means we need to multiply 10 by 3 and do the same thing to the top. And here the LCD, since it's 30, we multiply by 10, do the same to the top. We end up with 21 over 30 minus 10 over 30 is 11 over 30. So that means I get 11/30 y squared. So again, all we did is we combined the coefficients and we kept the variable the same. So now that we know how to combine like terms, we finally talk about using the distributive property. The distributive property is what allows us in math to combine addition and multiplication. In a sense, it tells us that addition and multiplication are compatible. So the distributive property says that a number times a sum is equal to the number times the second plus the number times the third. We can almost just think of the a as being distributed to both of these terms being added. We use this to get rid of parentheses. In other words, we use it to eliminate them. So let's do a couple of examples where we eliminate the parentheses. So using the distributive property. So first problem, this is problem 11. We have 2 times x plus 1. In this case, we're going to do 2 times x and then 2 times 1. So 2 times x is 2x, and then plus 2 times 1 is 2. So this is our answer. Okay. Let's do another problem. We're going to do negative 3 times x plus 5. Negative 3 times x plus 5. So in this case, we're going to do negative 3 times x and negative 3 times 5. Negative 3 times x is negative 3x, and then negative 3 times positive 5 is negative 15. Notice that the negative and the positive multiplied to make a negative. Another way to think about it is that this negative sign right here switches the sign of both of these. So since we started out with a positive x and a positive 5, we ended up with a negative 3x and a negative 15. Okay. Let's try another one. What if we have a subtraction in the middle? And I also want to add a second variable here. Notice in this problem I have a subtraction. The distributive property still holds even with minus. What's the rule? Well, a times b minus c is the same as a times b minus a times c. So it's the same exact rule except with subtraction. So 2 times x is 2x, and then 2 times negative 11y is negative 22y. Okay. Let's do one more example, the toughest case, the case that students make mistakes on all the time, is what if we have a negative on the outside and a negative on the inside? In this case, the negative is actually going to change the signs of both of these insides. This positive will become a negative, and this negative will become a positive. So let's do this problem. Negative 4 times 7x is negative 28x, and negative 4 times negative 2 gives us positive 8. So that's our answer. So we're finally ready for the topic, which is to add or subtract like terms and get rid of parentheses. In other words, we're going to simplify an expression containing parentheses. So what are the steps? It's just a couple of steps. The first step is to do what we were just doing, which is to use the distributive property to eliminate parentheses. And then the second step is to do what we were doing before, which is to combine the like terms. So let's try a couple of these examples to finish off this lesson. So the instructions here are to simplify the expression. So, number 15. 2 times 8f minus 1 minus 4f plus 7. Now in this problem, we have to get rid of the parentheses first before we combine like terms. So first I'm going to distribute the 2. So 2 times 8f is 16f, and 2 times negative 1 is negative 2. We still have the minus 4f plus 7, so I just carry that down. Now I combine the like terms. I notice I have a 16f here and a negative 4f here. Those combine to give us 12f. And then I have a negative 2 and a positive 7. Those combine to give us positive 5. And that is all I can do because 12f and positive 5 are not like terms. Let's try another one. we're going to do 5 times 3n plus 2 minus 4n minus 8. Now, in this problem, there's a couple of things that can throw people off. First of all, we have this minus sign here. This minus sign and this minus sign can throw a lot of students off. Just remember that the first minus sign is going to change the signs of both of the insides. You can also picture there being an invisible 1 here. So you can picture there being an invisible 1 right there. So let's go ahead and distribute. 5 times 3n is 15n. 5 times positive 2 is positive 10. Here we have negative 1 times 4n. That gives us negative 4n. And negative 1 times negative 8, that gives us positive 8. Combine our like terms, we have 15n and negative 4n, that gives us 11n. Positive 10 and positive 8 give us positive 18. And that's it. We can't combine terms any further. Very last example, we're going to make this more challenging with fractions. We're going to do 1/4 times 6 minus 5t plus 2/3 times 3t plus 9. It's going to be tricky because we have to use the distributive property here and we have fractions. So first we have 1/4 times 6. Let me go ahead and write that out next to it. And I'll do the subtractions later on. Minus 1/4 times negative 5t. So I'm just going to write 1/4 times 5t. And then plus 2/3 times 3t, 2/3 times 3t, and then plus 2/3 times 9. Now because I'm multiplying fractions, I'm going to put the second whole numbers over 1 in each case. For the first one, I have 1/4 times 6. I can go ahead and cancel a 2 out. So I have a 2 and a 3. I end up with 3 halves. This second one, nothing cancels. I just multiply across. I get 5t over 4. The next one, the 3's cancel. I end up with plus 2t. And then I get cancellation of the 3 here. I get plus 6. Now I'm going to go ahead and combine like terms. Be careful though, because we do have fractions. Notice in this problem I have 2t over 1. So first I'm going to go ahead and combine these like terms. This one and this one. So I have negative 5/4 plus 2 over 1. Remember, we add their coefficients here. So the LCD in this case is 4, so I'm just going to give this guy a 4 and a 4. I end up with negative 5/4 plus 8/4, which gives us 3/4. So far I have 3/4 t. Next I have the following. I have 3 halves, which I'm boxing, plus 6. 3 halves plus 6. So the LCD is 2, so I'm going to give this a 2 and this a 2. I end up with 3 halves plus 12 over 2, which is 15 over 2. So I go ahead and I combine those here. I get plus 15 over 2, and this is my final answer because we do not have like terms. And that's it for this lesson. Thanks very much for watching.